Have you ever wondered how to capture, analyze, and document functional requirements from the perspective of end users? Well, this is where use case techniques come into play. These techniques are a valuable tool in requirements engineering, providing a way to describe how users interact with a system to achieve specific goals or tasks. In our journey today, we will explore some commonly used techniques in use case modeling. We'll start by identifying actors and use cases, which are the external entities that interact with the system being developed. Then we'll move into writing detailed use case descriptions and creating use case diagrams. We'll also delve into the world of use case modeling techniques, prioritization, and realization. Finally, we'll touch on validation, verification, and iterative refinement. These steps will help us ensure that our use cases accurately capture user requirements and expectations, and are complete, correct, and consistent. So, let's dive right in and start with the first technique: identifying actors and use cases. The first step in use case modeling is to identify the actors and use cases. In the world of use case modeling, actors aren't the Hollywood kind, but rather external entities that interact with the system being developed. These could be users, other systems, or even devices. The key is to identify who or what will be interacting with your system. These actors play crucial roles as they define the various perspectives from which your system will be used. Now, let's talk about use cases. These are essentially the goals or tasks that the actors want to accomplish with the system. You see, every interaction an actor has with the system is driven by a desire to achieve a certain goal. This could be as simple as retrieving information or as complex as conducting a multi-step process. When identifying use cases, think about what your actors want the system to do for them. What tasks are they trying to accomplish? What goals do they have? Remember, these use cases should be meaningful from the actor's perspective. By identifying actors and use cases, you create a solid foundation for your use case model. It's like mapping out the key players and their objectives in a game. This step helps to ensure that your system's design and development are focused on meeting the needs of its users. Once you've identified the actors and use cases, it's time to write detailed descriptions for each use case. Writing use case descriptions is a critical step in capturing functional requirements. This process allows us to delve into the details of how a system should behave in response to user interactions. Let's break down the elements that make up a comprehensive use case description. First, we have the name. This should be a concise yet descriptive label for the use case. It's like a headline, capturing the essence of the interaction in just a few words. Next, we move to the description. This is a brief, high-level summary of the use case, explaining the purpose and the value it provides to the user. This part doesn't delve into the specifics of the interaction, but it gives an overview of what the use case is all about. Then we have preconditions and postconditions. Preconditions outline the state of the system before the use case can be initiated. It's like setting the stage for the interaction to take place. Postconditions, on the other hand, describe the expected state of the system after the use case has been completed. It's like the finale, showcasing the results of the interaction. Now let's talk about the main flow of events. This is the heart of the use case description. It outlines the sequence of actions and interactions between the user and the system step by step, from start to finish. It's like a dance choreography, detailing every move, every response, every twist, and every turn. But life is full of surprises, and so is our system. This is where alternate flows come in. These describe deviations from the main flow, triggered by certain conditions or exceptions. Alternate flows show how the system handles different scenarios, ensuring it can dance to any tune, any rhythm, any beat. In essence, writing use case descriptions is like writing a story. It's about creating a narrative of user-system interactions, bringing to life the functionality of the system, and showcasing how it meets user needs and expectations. After writing detailed use case descriptions, you can create a graphical representation of the system's functionality using use case diagrams. Use case diagrams provide a visual representation of the system's functionality. They are the graphical illustrations that encapsulate the relationships between different actors and the use cases they interact with. An actor here can be a person, a group, or an external system that plays a role in our scenario. To create a use case diagram, we start by identifying all the actors. These are the external entities that interact with our system. They could be users, other systems, or devices. We then identify the use cases, which are the tasks or goals that these actors want to accomplish. Once we have our actors and use cases, we map out their interactions on our diagram. Lines or arrows are used to denote these relationships. For example, if a user can log into a system, we would draw a line from the user actor to the login use case. It's important to remember that use case diagrams don't detail the order in which these interactions occur. They simply depict the relationships. The order or sequence of events is typically outlined in the use case description or represented in other types of diagrams like sequence or activity diagrams. The beauty of use case diagrams is their simplicity. They provide a high-level view of system interactions, making it easier for stakeholders to understand the system's functionality without delving into the technical details. Now that you've created your use case diagrams, it's time to delve into use case modeling techniques. Use case modeling techniques help describe the sequence of steps that occur during user-system interaction. Let's delve into the heart of use case modeling, where we unravel the journey of user and system interaction. This is achieved through the use of various techniques, including the basic flow, alternate flows, exception flows, and include and extend relationships. Starting with the basic flow, this describes the typical sequence of steps that occur when a user interacts with the system to accomplish a task. It's the ideal scenario, where everything goes exactly as planned. The basic flow provides a roadmap for the user's journey, from the start to the successful completion of a task. But life isn't always a smooth ride, and neither is a user's interaction with a system. That's where alternate flows come in. These describe alternative sequences of steps that occur when certain conditions are met. It's like taking a detour when the main road is blocked. Now, let's talk about exception flows. Exception flows document what happens when things go awry. They describe the system's response to error conditions, ensuring robustness and effective error handling. Think of them as emergency exit routes when things don't go according to plan. Last but not least, we have include and extend relationships. These are used to modularize use cases and handle common behavior or optional features. Include relationships depict a use case that is always executed as part of another use case. It's like a chapter in a book that's always read as part of the story. Extend relationships, on the other hand, represent optional use case behavior. It's the bonus content that can be accessed, but isn't necessary to complete the main story. With these techniques, you can construct a comprehensive map of user-system interactions, capturing all possible paths, detours, and emergency exits. With your use case models in place, you can now prioritize them based on various factors. Prioritizing use cases helps determine their order of implementation. This process is crucial in project management, as it aligns the development work with business value, user importance, technical complexity, and project constraints. One popular technique is the Moscow method, an acronym for must have, should have, could have, and won't have. This method helps stakeholders determine the criticality and importance of each use case. Once we've prioritized our use cases, we move on to use case realization. This is where we describe how each use case will be realized in the system's design and architecture. It's about detailing the dynamic behavior and interactions between system components during use case execution. We often use interaction diagrams, such as sequence or activity diagrams, to illustrate these interactions. Remember, a well-prioritized and realized use case is only as good as its validation and verification. Once your use cases are prioritized and ready for implementation, it's important to validate and verify them. Validation and verification are crucial steps in ensuring the accuracy and completeness of use cases. Validation involves checking with stakeholders to ensure that the use cases accurately capture user requirements and expectations. This is all about making sure that we've built the right system. On the other hand, verification is about making sure that we've built the system right. It involves checking the use cases against acceptance criteria and quality attributes to ensure their completeness, correctness, and consistency. But the journey doesn't end there. Use case development is an iterative process, and it's important to continually refine and evolve use cases throughout the development lifecycle. This iterative refinement is driven by feedback, changes in requirements, and emerging insights. It's about learning and adapting, improving your understanding of the system and its users, and making better decisions as a result. And there you have it, a comprehensive guide to use case techniques. Remember, practice makes perfect, so don't be afraid to refine and evolve your use cases as you gain more insights.